Now, entry is scheduled for 11:47. The cruise date SEP and the entry times are locked in, correct?
They are. They're locked in when we selected the target and aimed the vehicle very precisely. That allows us to know exactly when we hit the entry point, which is 55 kilometers from the center of Mars.
So we know those times are locked in, but what about all the other events that take place in EDL?
Radio Science reports dropping carrier power as expected.
Marco A and Marco B have telemetry.
Just heard, both Marcos have telemetry.
They are doing their job. These small CubeSats are relaying ones and zeros with a few seconds lag from the vehicle up to these two vehicles, and they forward them back to Earth to the Deep Space Network using X-band antennas.
And keep in mind, this was all an experiment. We weren't sure that this was going to work, but we had this need that we didn't have live communication in this particular mission.
Well, we don't really need communications. We don't need their information, except if something went wrong. We would very much like to get the data right now. We have other spacecraft.
We are now receiving InSight telemetry via the Marco relay.
It's flowing into their station. This is fabulous. That means the team now can watch the data flowing onto their screens as if they're commuting directly.
This data will provide detailed information about the state of the spacecraft throughout EDL.
We were on pins and needles waiting for that because we weren't really sure.
This is wonderful news. This will allow us to give some, if this continues working all the way to the ground and beyond, we might even see a first picture from the surface of Mars.
Wouldn't that be great?
Very soon.
Atmospheric entry on my mark. 3, 2, 1, mark.
Here we go.
So in a few seconds, the vehicle will start sensing the atmosphere. I said 22 kilometers from the center of Mars, and it's going to start to slow down very, very slowly at first, but then faster and faster and faster till to reaches about 7 Gs. I made that mistake on the video. It's actually 7 Gs, not 12, and so but we'll still very, very quickly slow down, and from 15.
In approximately 1 minute, InSight is expected to reach its maximum heating rate.
Oh, yes.
Plasma blackout is possible during peak heating and could cause a temporary dropout of telemetry. This could last for as long as 2 minutes.
Yeah, the gas that comes off the heat shield as it's slowing down, it looks like a meteor if you're on Mars watching the streak go by. That brightness of gas does interfere with the radio reception. And so it's possible that Marco will lose that signal while it's going through this very hot entry.
But not to be alarmed.
Not to be alarmed. It's part of the design. We completely expect it.
Radio Science reports plasma blackout as expected.
Okay. Oh, wow.
Ground stations have reported plasma blackout, still receiving InSight telemetry via Marco.
Marco Alpha has carrier interruption.
InSight should now be experiencing the peak heating rate. Portions of the heat shield may reach nearly 3,000 degrees Fahrenheit as it protects the lander from the heating environment.
That's hot.
Marco Bravo shows carrier interruption, but still in lock.
InSight has passed through peak deceleration. Telemetry shows the spacecraft saw about 8 Gs.
Marco Alpha and Marco Bravo maintain lock.
Radio Science reports carrier detected.
So, several different communications coming in.
InSight is now traveling at a velocity of 2,000 meters per second.
It seems to have passed this very critical point of peak heating and peak deceleration. next big step is parachute inflation.
And you can see that on our timeline on the bottom of the screen. The next event is parachute deploy.
InSight is now traveling at 1,000 meters per second.
Very close.
Once InSight slows to about 400 meters per second, it will deploy its 12-meter diameter supersonic parachute. The parachute will deploy nominally at about Mach 1.7. Standing by for parachute deploy.
Radio science reports sudden change in Doppler.
Ground stations are observing signals consistent with parachute deploy.
Marco Alpha, Marco Bravo, maintain lock status.
Telemetry shows parachute deployment. Radar powered on. Heat shield separation commanded.
This is really good news so far.
It's fantastic.
I'm on pins and needles.
We have radar activation, where the radar is beginning to search for the ground. Once the radar locks on the ground and InSight is about 1 kilometer above the surface, the lander will separate from the backshell and begin terminal descent using its 12 descent engines. Altitude convergence, the radar has locked on the ground.
Yes!
Standing by for lander separation.
Carrier interruption on Marco Alpha and Marco Bravo.
Lander separation commanded. Altitude 600 meters. Gravity turn, altitude 400 meters.
We're getting there.
300 meters. 200 meters. 80 meters. 60 meters. 50 meters, constant velocity. 37 meters. 30 meters. 20 meters. 17 meters, standing by for touchdown. Touchdown confirmed. InSight is on the surface of Mars.
Wow.
That's fantastic.
This never gets old.
No, it doesn't, Rob. Control
what a
room
relief.
just erupted.
Fabulous,
Shaking
fabulous.
hands with the Marco
Marcos.
team there.
Christine, you did great. Jim Preiser, one of the key designers at Lockheed. Sandy Krasner, what a great
relief.
team. What a great. This is really fabulous.
Fantastic news.
Thank you.
Lots of fist bumping going on in there. What a relief. We've cut over to the camera over in Times Square. Boy, people are weathering the rain to see this.
They can't hold. This is the hardest part. Getting to the surface of Mars is very hard. This thing has a lot more to do, though. There's a lot more to go on both today and the days that follow before the science can begin. But just getting a vehicle from Earth to the surface of Mars is no mean feat.
And Rob, could you talk about that? I mean, just the mere accomplishment here that we're seeing.
You have to understand that this vehicle is very complicated. It uses 12 engines. Each of those engines are pulsed 10 times a second, producing these little tiny impulses, almost like little bullets that keep the vehicle going at a constant velocity as it approaches the ground, and still going over 5 miles an hour. So those legs feel a fair amount of crush. We still don't know the state of the vehicle right now. We need to look to make sure there are no rocks nearby. The solar panels will be in just a few, in about 5 to 10 minutes, will begin to open up. They're waiting for the dust to settle, because the dust there's certainly a lot of dust being lifted in the air around the vehicle right now, which is now just settling.
So we're standing by. After touchdown, it waits a couple of minutes to give us an X-band beep. And so we are standing by for that. It's a communication that comes directly to Earth from InSight.
Yes. And it goes to the Deep Space Network. There's also something that might be happening now, if we're very lucky. InSight might be able to relay an image or a partial image taken just a couple minutes after landing. So I'm standing by hoping to see that. But if that doesn't happen, we'll certainly get more images later in our Odyssey pass in about 5 hours.
We see Bruce Banner waiting for it.
They're looking
I don't know if they see it yet.
They're waiting. That's Justin Mackey and Bruce Banner looking carefully at the cameras to see what they might see. Waiting for the image to come back.
So this is the first image from InSight itself. InSight is taking a picture with one of its 2 cameras.
Yes.
It's probably a view of what's directly in front of the spacecraft, right in front of the lander. This is a camera that it would be using to figure out, is this a good space?
Exactly.
Is it a good place to put down our instruments? So it is going to take an image and then send that image to the Marcos. The Marcos, in turn, will relay it back down to Earth.
That's correct. They got it. Oh, now
Let's
let's just wait. Let's see what they saw. There it is. Wow, right.